So my name is Lewis Benge. You may or may not have seen me speak before. I've been here for around 6 years at this particular conference. I've also presented over in New Zealand as well. I actually work for one of the big four banks. I'm a lead architect looking after the retail banking space. So I do a lot in what Microsoft are now coining digital transformation. But my journey's seen me across a whole load of different retail applications from B2B, B2C, working around bringing traditional retail, financial services, retail banks along that journey. So I've actually talked in previous years about a whole load of different things, including mobility, embedded, IoT. And now today I'm actually here talking about some of the bare basics and back to some of the core of our engineering principles. It's exciting for me because I'm an architect, so I'm used to normally just drawing boxes on a whiteboard and arguing with engineers. So this time I get to hopefully be somewhat more hands-on. So I'm going to talk today predominantly about .NET standards. So I'm on the assumption that a lot of you guys, being at a Microsoft conference, know about .NET, have used .NET, and know C#. If not, this is a level 300 talk, so this may be a little bit out of your depth, but if you have questions, feel free to ask as we're going along. So as I say, the first thing we need to talk about today is .NET Standard. It's the new way that .NET is heading, and it's going to introduce a lot of changes to the way we start thinking about .NET applications in the future. But before we think about .NET Standards, we need to look at what is going on with .NET today, and what has gone on with .NET for a number of years. So let's take a step back and talk about the current ecosystem. Where we're currently at with the Microsoft-owned products is we've got these disparate independent .NET platforms. We have the .NET Framework, we've now got .NET Core. Microsoft obviously recently acquired Xamarin and the Mono piece that sits under the top. And off to the side, you've got the stacks such as Unity 3D and the other frameworks that are also using .NET as well. It's great as a .NET developer. This actually empowers us hugely because we can go and build applications and we can go and build an iOS app and compile it down, and then that can use an ASP web API running on .NET Core hosted on Linux, and then we can go and have a thick client WPF app running maybe a management app or CRM in the back end, and they all talk to one another. And we can all kind of write codes that we can potentially share across this. The issue we have, however, is all of these independent stacks have different base class libraries. The issue we've got with this is as the stacks have grown out, it's become really difficult to actually start to look at how we engineer code for reuse. Having been one of the original trainers on Windows 8, I've gone along the Windows RT journey, and I've gone along the Windows RT journey as a person that builds embedded applications. So I've learned the lesson the hard way around having access to things like serial ports and particular serialization protocols that in this style of fragmentation of the platforms, we start to lose. So writing shared code that maybe once we would want to deploy on a WPF app and then bring into WinRT or Silverlight or onto the phone, actually having that reusability isn't always an easy thing. As a result, you're constantly having to upskill as well. You're having to kind of keep looking around what's going on, which APIs are where. And I remember every time that Microsoft would release an update to 8.1 when the Insider program came out, I'd be sitting there with just decompile, looking at the new API profiles, trying to figure out what's coming in the next release so we can actually build some of this stuff. The biggest part about the base class library as well, and the fact that these keep changing out, is these are the core foundations of some of the things we do. So if we lose capability like serialization, like some of the networking stack, as we kind of jump around these as well. And we also start to see that as Microsoft evolved the .NET framework, they like to play with it and trying to innovate at the same time. So if you've ever used the .NET Core, you'll start to see things like the reflection APIs have actually changed. So what we've previously done in the past are continually being iterated on and innovated on, and it means that we're having to relearn and upskill as a result. So Microsoft have decided to move away from this. They want to now standardize the way the .NET framework is actually going to start to be produced moving forward. So what they've now created is a single base class library called the .NET Standard. The reason for this is, I can manage to break my screen. It allows us to figure out what the core framework is and what the surface area of that framework is, and we can code towards that. Means that as new platforms stand up, they can also adhere to this standard and start actually designing around that. And it also means that the platforms can innovate at their own pace as long as they're conforming to a standard and an application developer knows what they're actually developing against. So what exactly is the .NET standard? Well, it is a standard. It's a standard as in HTML5, as in ECMAScript, as in some of the JavaScript standards. It represents a set of APIs that everyone has to conform to when they actually build this platform. So as an example, the latest version of Xamarin that conforms to a .NET standard will have to build the same set of APIs as the version of .NET Core that conforms to that standard as the version of .NET Framework that builds that standard. It's a governance model that's now ensuring that all of the platform developers are working together to make sure that we have the support we actually need. It also does come with a set of tooling. So the standard itself is not something that we typically develop against. We develop against the frameworks, the platforms that we want to deploy to. But there's a set of tools in the form of a class library inside Visual Studio 2017, which is the one that's in the screenshot here, and NuGet packages that allow us to actually see the API set that we can actually develop against. So when we talk about standardization, a lot of people say, well, isn't this the same thing as a PCL, a portable class library? And in some ways, you're correct. So PCLs were originally designed to solve this problem. But PCLs have always been an afterthought of the .NET platforms. When the individual .NET stacks were stood up, they were stood up in isolation, and no one really thought about sharing code between them. And sharing code has now become a first-class citizen. So when portable class libraries came around, the .NET Framework team decided to try and help the community by building up a way of allowing us to use the code against the various .NET platforms. The way they've done this is by coming up with this concept of a profile. So essentially what it's doing is it's allowing you to actually create a class library and saying, I want to select individual platforms. I want to target Xamarin iOS. I want to target Xamarin Android. I want to target .NET Core. Then it computationally calculates exactly what API subset you can use, and then it attaches a profile name to it. That intersection of the Venn diagram is exactly what that profile takes. The problem is that you never know exactly the problem with it is if a new platform comes along, what you've actually developed and what you've compiled and what you've deployed into NuGet then can't be used by the new platform that's come along. So if you've developed your platform for Android iOS, Xamarin iOS, Xamarin Android, UWP, .NET Core, and all of a sudden a version of Unity comes along where you think, wouldn't it be good if I could use this code within Unity 3D? If you've already compiled to that subset and you've got a profile there, being able to then add your NuGet package to Unity 3D means you've got to go through, you've got to recalculate a new profile, you've got to repackage it, you've got to deploy it to NuGet, and now you've got to manage two different libraries and the dependencies between them. It was designed with good intentions, but it's actually really hard for people to continually manage this. The other part of it is these profiles, they're all numerical based, and they actually have no meaning to them. So you could have a profile 8 and a profile 77. There's actually no linkage between them numbers. You don't know what the coverage, the API set is, what the supported targets are. So when you're actually then going inside of NuGet, you're going inside to deal with any of the PCLs, and you're looking to say, oh, I've got target 107 and target 88, you don't know which one to use where. It becomes very, very complicated. So I've actually got another session tomorrow, which is a Xamarin session, and I kind of run into exactly this problem. So I'll switch to my developer machine, and I'll jump into my portable class library solution. So the demo I'm doing tomorrow is a Xamarin Forms demo. I've got an iOS application, I've got an Android solution, I've got a shared code library, And I actually wanted to create a portable class library. The reason I wanted to add a portable class library in here is I wanted to build out some functionality that eventually I could take off to maybe something like an IoT device like a Raspberry Pi. So I'm just going to add this portable class library in, and I'm going to select the kind of the defaults out of the box, which is the Xamarin platform, Android, iOS, Mac, .NET framework, and I won't even use UWP or the core. So now I'll go off and create me this portable class library. And then what I wanted to do for my demo that I'm going through tomorrow is I wanted to install a MVVM framework called Calibre Micro. So it pops up in Nougat, I could go install. And what you actually see is the whole thing's just completely errored on me. So this framework is designed around Xamarin and UWP. It should just work. It's how the packages were designed. That's the reason that exists in this in the package manager. But what it's actually saying, and the error down the bottom, is could not install package Calibre Micro. You are trying to install this package in a project that targets .NET Portable version 4.6, profile 44. But the package does not contain any assemblies or references that are compatible with that framework. So how do I fix it? Like, as a developer, this is just me now having to go round and round in circles until I find a .NET Profile solution, a .NET Profile combination that would allow me to add this PCL in. So .NET Standard attempts to fix this for us. It attempts to standardize the way we talk about .NET and moving away from these computational profiles into a bit more of a semantic versioning. So the first thing it does is it gets rid of profile numbers altogether. It starts off with 1.0 and scales all the way out to where we are today, which is at 2.0. Also removes this whole concept of the Venn diagram, the interconnected points at when profiles may touch one another. The way the .NET Standard actually works is the smaller the number, the earlier the version, obviously like everything API, 1.0 is the original one. And then any other version that surrounds it, 1.3, is an extension of 1.0. It keeps building and building and building and building. So whatever was in 1.0, you can guarantee is in 1.3, you can guarantee is also in 2.0. Makes it nice and easy to consume. The newer version of the standard also gets fatter, has more and more APIs. So 1.0 started with a small subset, and it actually had a smaller base of clients that could actually consume it. The bigger you go out, 2.0 actually doubles the amount of APIs you have access to. So it grows in proportion. So the diagram that is actually visualized on the screen is a nice, easy way to remember how it's actually working. Sorry, 2 seconds. So 1.0 being that center, 1.3 is growing it out, and as it's swelling out, it's adding more and more content in it as a result. So I've got a few questions.
So it's not semantic version, so 2.0 is not breaking.
Sorry, that is correct. It's not actual semantic versioning. It's just it's the logical version out of 1.0, and then it increments as it grows out.
What about deprecation of functionality?
So I'll go into this in a sec. I'll actually show exactly how you can get the diffs and stuff between the particular APIs. I'll take one last question, and then I'm going to move on. I will cover that in a little bit later as well. I'm glad everyone's really excited about this. So the easiest way to show you exactly what is going to get covered in these APIs is by actually showing you. So as we know, Microsoft is now all about putting code in the open source, and .NET Standard is no exception. So if I jump to Chrome, the best place to take you is to the actual .NET Standard library. So if you go to the .NET Standard repository, so if you go to github.com/.NET/standard, you actually get access to all of the code. Inside the code is the docs folder, as with every good library. And the things you actually want to now start looking at is, firstly, if I'm not making a whole load of sense to you, there's an FAQs markdown document that I encourage you to read. But the versions markdown document is where you actually want to go to. So this table here that you can hopefully see on that screen, and I'll zoom in a little bit bigger to make sure it's clear, actually shows you what the exposure set of the .NET platforms actually are and what's currently being covered. So if you look at that 1.0, it's actually covering a lot of our legacy. So it's got all the way from .NET Core down to Silverlight. As you actually go further and further up the stack, the API set's going to increase, but that actually means that the platform support's going to reduce at the same time. Silverlight obviously doesn't have all the APIs that are in UWP, so you start to drop off some of them platforms. But what you do get access to is the new APIs. So how do you actually know what's in here? So the easiest way to actually have a look is all of these version numbers at the top are hyperlinked. So as an example, if I jump down to 1.4, you can now see specifically what's actually supported by this standard. So the platform support is .NET Core, .NET Framework, Mono, Xamarin iOS, Xamarin Android, and UWP. What's new? They've added a whole load of cryptography APIs. So the delta between 1.4 and 1.3 is actually fairly small. Specifically, I can jump into a diff, so I can actually see what's changed. So when we talk about what's been deprecated versus what's been added, this is where we can start to see this information. I can also then jump back in and see the full API set. It's actually fairly useful because I can go, well, does something called a data set exist? No. So I can't use a data set. I can't use system.data.dataset, I think the original API was. But I can see exactly what is covered in every single API within the .NET Standard 1.4. The other place we can get this information is an open source project called APIs of .NET. So this is actually a really interesting one if you're constantly jumping around the .NET stack. So it's just basically an API catalog. So it does allow me to do things like search, dataset. And it comes back with system.data.dataset. I've just clicked on the wrong thing. And then what you'll actually be able to do is, off the back of those search results, I can actually now jump down and go, oh look, .NET Standard 2.0 now supports system.data.dataset. So if there's particular APIs you're actually looking for, it's a really good tool that will tell you how to get to .NET Standard. Also very, very useful for Xamarin and Unity and .NET Core and .NET Framework. You can navigate around and figure out what's supported where. So it wouldn't be a Microsoft talk if things change, if things hadn't have changed recently. And of course, we had .NET Core, we had .NET Standard came out, and then they went and changed everything on us. And these changes are actually fairly recent. So I want to talk to you a little bit about what's new in .NET Standard 2.0, which is the upcoming release of .NET Standard that we're going to start to see after the release of Visual Studio 2017. So firstly, Microsoft have had a fairly good response with the current .NET Standard, which is 1.6, and all of the subsets of that. But people continually say that .NET Standard doesn't have enough API coverage, and this is the same for .NET Core as well. There's not enough that we could have previously done in ASP.NET and the .NET frameworks that we can now deploy in .NET Core and onto these other stacks. So the biggest thing that we notice within the difference between .NET Standard 1.6 and 2.0 is the number of APIs. So we've now gone from 13,000 APIs to 32,000 APIs. The breadth of those APIs are actually very aligned to what enterprise developers need, and I'll jump to some of the examples of that in a sec. The second issue that people are facing is people are still relying heavily on .NET Framework-based dependencies when building out applications. So it could be that you've got a library that's inside a PCL that you're trying to convert to a .NET Standard library, but somewhere up the chain there is a .NET Framework dependency. So one of the things that .NET Framework 2.0 gives us is a compatibility shim. It allows us to start thinking about backwards compatibility with .NET Framework APIs that we don't necessarily have to completely recode. So if there's a hard dependency somewhere we don't have the source code for, we can potentially bring it forward using one of these compat shims and actually getting it working inside .NET Standard and then potentially inside .NET Core or on Xamarin as well. There is a caveat to this though. The guys always say magic doesn't exist. So if your API, if your .NET Framework API contains code that isn't in the standard, things like WPF code, specific Silverlight code, and there is no way of getting compatibility, you can't bring it forward. But if you've got things like legacy HTTP clients, so you're maybe using some of the older methods of doing that, the shims will actually help you get your code up to modern specs. So I talk about the increased API coverage. So let's have a quick look at what's actually been added into. I'm so glad my slides formatted correctly. So let's have a quick look at what's been added into 2.0. So some of this stuff is actually exciting for me. I've said that I do a lot of stuff in embedded. So the first thing that we actually talk about is reflection. So the way reflection was being handled, as I mentioned earlier in .NET Core, completely changed. The APIs that were being introduced were fundamentally different to the way reflection was being handled in .NET Framework. All of the legacy way of doing reflection has been brought back into .NET Standard 2.0. Some of the other big changes is we've actually got the majority of system.data coming back into the standard now. So things like data table and data set, which a lot of legacy enterprise applications are still using, are now in scope to be upgraded. For me, one of the big things that I'm kind of glad to see is support for increased serialization overhead. Again, I'm a geek that likes playing with embedded. I also do a lot of work with Apache Thrift. Apache Thrift is a binary serialization format, and it's used for things like Storm, Spark, and all of that kind of stuff. For me to be able to write code against this stuff and get it deployed on Linux, I need binary serialization. All of that is coming back into Standard 2.0, as well as the full support for XML serialization, XML schemas, XPath, and XSLT. So I want to quickly show you some of the stuff that we can do with .NET Standard 2.0. So the first thing I want to show you is the difference between the API sets. So as with any good developer, we want to do something with serialization. So because these APIs were, I think, written in 2001, I've just Googled how to do object serialization. So this is the first thing that pops up onto Google, and I've got a piece of code, so I'm going to do exactly what I see people do at work, and I'm just going to copy that code, and I'm going to come into my project. So first thing is I've got two .NET Standard libraries here. I've got a .NET Standard 1.6, which is the current supported standard, and I've also pulled down off of GitHub .NET Standard 2.0, which is pre-release code, and I've compiled this myself to get it up and running. So all I'm going to do is I'm going to come into my class library, and I'm going to just dump the code that I've copied off of the internet. The first thing it was a serializable class, and then I'm actually going to take the serializable content, and I'm just going to write a method which is called test. Okay, so obviously what will happen now, hopefully, is because that API footprint doesn't exist, binary serialization doesn't exist in the standard 1.6, I can't add the references to anything I need. It just doesn't exist in the IntelliSense. The compiler can't find any of the APIs. Luckily, though, 2.0 comes to save the day, so I can actually jump into a 2.0 class. I can paste exactly the same code, and the magic kicks in, and it suddenly starts to compile. So that sounds all well and good. It's pretty obvious. I've told you that the API set's increased, and we can start to use this stuff with an increased API set. But how about we do some more stuff with legacy? So it's always good to go and find some really old stuff on the Coplex, because it's the place you look for old stuff. One of the most used projects on Coplex is Winterlex Power Collection. So it adds a whole load of extensibility to a systems.collection namespace, and it gives you things like bag and stuff like that. It was created in 2005, and it was last touched in 2007. So it's very much a .NET framework project. It was last touch before PCLs were even supported by the .NET Framework team. So I've downloaded this code, and I've got the binary. So the first thing I can do is I can go and try and add this .NET binary to my .NET Standard 1.6 project. And Visual Studio breaks. Okay, that's not going to work because Visual Studio 2017 has still got a bug in it. So when I'd done this demo earlier today, and I tried it about 3 times and didn't get that, I can add that. I can add that assembly to .NET Standard 1.6. Sorry. Close it. I'm so glad this is going up onto Channel 9. While we're waiting for my VM to catch up with me, has anyone got any questions? Okay, there we go. Hey, it works. Okay, so I can go and add a .NET Framework assembly to a .NET Standard 1.6 project. And it adds, it's fine. I can then go and start to write code against it. So I can say, I've got this method up here, which is get numbers and returns an IEnumerable of type integer. I can actually go return new bag of type integer. I can initialize that with just a small array of numbers. What you'll notice is, again, it can't find any references to that assembly. So although I've added it in and it hasn't had an issue with me adding in that .NET Framework assembly, it can't actually see it. The class library doesn't actually understand it exists. Whereas in 2.0, if I repeat that exercise, and then I actually copy that same bit of code across, oh, I was in the 2.0 project. So in the 2.0 project, it actually, recognizes the WinSelect's Power Collections library. The IntelliSense kicks in, and it actually lets me compile it. So I've now got a .NET Standard 2.0 library referencing a piece of .NET Framework code which was written in 2005. And if I wanted to go one step further and I had access to the tools, I can now actually deploy this in .NET Core using .NET Core 2.0 onto my Mac. So it's actually that compatibility shim kicking in, which is allowing us to take .NET Framework code and actually start to run that across the multi-platform support that .NET Core now gives us. So one of the things that we just obviously want to be aware of is when we're actually starting to write libraries is how do we go about actually checking compatibility of the libraries that we're referencing in either libraries we want to consume or in .NET Core applications or various applications that want to be able to leverage .NET Standard capability. So luckily, there are a whole load of tools that come along with the standard that allow us to do this. So again, I'm going to kind of jump back onto my Windows machine and talk you through exactly how to get here. So one of the first things I want to show you is, again, on GitHub, there is a great little application called API Port. So if you actually just Google API Port, or you go to github.com/microsoft/.net-API Port, you can download the binary, which is a console-based app and executable that you can run at the command line. There's also a good little Visual Studio plugin, which I'll show you in a sec. This tool is awesome for actually not just .NET Standard, but any type of cross-compatibility issues you have around being able to scan binary files. And I want to show you exactly how that works. So I'm going to use exactly the same library as I was just playing around with in this Visual Studio project. And what I've actually got is a copy of API port down here, and I've got a copy of the Power Collections assembly. The reason that the console app is so good is because if you've got a whole load of solutions that use dependencies from all over the place, you can actually automate this in PowerShell and actually just go and run the whole thing across all the binary files you have and get an output of where exactly your project is in terms of support for the .NET Standard. So how we do this is we call the API port.exe project, and we use the analyze method. And then I just give it a target of the Power Collections DLL. Sorry, a file of the Power Collections DLL. What that's going to do is it's going to look at that assembly, it's going to look at the API footprint, it's going to look at everything that we're using inside that assembly. And what it actually does is it spits me out an Excel file. So if I now jump into my file system and open that Excel spreadsheet, what you'll see is it's actually scanned it at the version of .NET Standard that is currently default for my machine, which is 1.6, it's the latest release version. And it's told me that that API is currently 92.56% compatible. Excel is a great way of actually us being able to break down this data. You can also spit this out as HTML if you want something a little bit easier to consume as a report. Having a number like that, 92.56%, is kind of useful. What's actually a little bit more useful is it tells me the exact issues it's got with that API. So if I actually have a look at some of the things it's calling out to me, things like iClonable, currently not supported. The support for .NET Standard comes in 2.0, but it's actually giving me advice if I want to try and get that standard earlier, maybe just remove the usage of iClonable. The other things it's talking about, my good old friend serialization, currently doesn't exist. We know it's coming in 2.0, so it's giving me a piece of advice where it's saying maybe remove serialization info from this exception or use a different serialization technology. So it's actually quite intelligent in some of the advice it's given us. But what if we actually wanted to see, is it compatible with 2.0? So what we can actually do is use the same tool, and I can say, show me all versions you target. Sorry, list targets is the command I was looking for. So what this is doing is now looking at all of the different versions of the .NET platform I have installed on my machine. Sorry, that's not very large. What you'll actually see is .NET Standard is there. I've got .NET Standard all the way of 1.0 through to 2.0, and the one with a little asterisk next to it, which is 1.6, is the one that's currently defaulted on my machine. For me to actually change what I want to target, I can actually use this command, which is it's exactly the same analyze command with -F for file, the file I want to analyze, -T for target, and then I'm saying .NET Standard version 2.0. If I hit enter, it's going to do exactly the same thing again. It's going to spit me out an Excel spreadsheet, which I'll then go and open for you guys. And what you'll see is it's now green. It's now 100% compatible with .NET 2.0, .NET Standard 2.0. We know that because we just run it in Visual Studio. We just compiled it, and potentially we could consume it in .NET Core. So as a reporting tool, it's actually really awesome. It's also really awesome for, as I say, any kind of analysis you want to look across the various .NET framework stacks. So if you want to take an API and say, can I use this just in Xamarin? You can use the same command and actually use that target to say, Xamarin.Android and the particular Xamarin Android version. It will spit you out the same content as well. So this is good for binaries, but what about if we actually want to look at the source code? Because this would be really good if we could get inline context around exactly where in the source code some of these issues are. So the same tool has actually been ported as a Visual Studio extension. So what I'll actually do is I'll open up the source code for Power Collections. And what I'm actually using here is under Extension Manager. You'll see that I've got this tool that's called .NET Portability Analyzer. That's the API port executable that's wrapped up in a nice Visual Studio extension that you can actually just download. This works on Visual Studio 2015 and 2017. What that does is it gives me this nice little piece in the command in the context menu where I can actually go analyze project portability. What I can also do is go portability analyzer settings. And it will actually let me target which platforms I want to look for as well. So in this instance, I want to be able to jump down and say .NET Standard and support for 2.0. I'll right click and I'll go Analyze Project Portability. And this is now essentially running a build of my code. So it's running exactly the same thing as it's done in the command line. It's generated me the same report. There's the Excel file. What it's also done is it's given me messages. So you've got the errors that are spitting out of the compiler. What I can now do is that iClonable issue that I was talking about earlier, of remove iClonable, if I now double click on this, it's going to jump me to the exact line of the code that's using iClonable, and then it's giving me that same advice if it's not currently supported, so maybe consider removing it. So it's a good way of you using these tools to go through and help refactor some of the code libraries that you have access to as well. Sorry, I wanted to show you one more thing. So there's one more tool that's really useful that's been called out to me as well. And it's a web-based tool. So I'm just going to jump back into Chrome. I'm going the wrong way on my clicker. So this one is more of a .NET Core style tool, but it also has a similar kind of structure to the tools we've just been looking at. So this one is called iconhas.net. And the way this actually works is you actually upload a NuGet package, or you can scan a GitHub repository. And if I click demo here, what it actually pulls out is a dependency graph and then gives you the compatibility for .NET Core. So this obviously isn't going to be specific to .NET Standard. It's not going to help you with a .NET Standard issue. But what it will start to do is when we start to look at cross-compatibility around .NET Standard into .NET Core and onto other stacks, I can go along, and this one here, which is a Serilog, is the project that they use as a demo. I can go through and say, well, all of this is supported, but Microsoft.NET.HTTP, there's something that I can maybe go and tweak or let me get support. But there is something, however, that is currently unsupported within .NET Core. So that's another really good tool to have under your belt if you're starting to explore the .NET Core world as well. Okay, back into the presentation. For the last little bit, I want to talk to you quickly about how this is actually working under the covers. So firstly, .NET Standards is a couple of things. So we talk about .NET Standard as a standard, but there's a way that this is actually working down at the compiler for it to stitch everything together. So there are two ways that we start to think about .NET Standard. Firstly, there's the NuGet package called .NET Standard Library. It's a weird one to say. This is a NuGet package that's available in NuGet today. It contains the dependencies for .NET Standard 1.0 through to 1.6. As we move forward into .NET Standard 2.0, we also are starting to introduce this concept of a reference assembly called Net Standard DLL. The reference assembly is essentially a facade. So what the reference assembly is there to do in the Net Standard DLL is it provides the API set for what is covered within .NET Standard, but doesn't actually contain any implementation or any code. It's there just to help the compiler through what it needs to do. What's actually happening under the covers is at build time, .NET Standard is using Net Standard DLL to type forward everything it needs to through to the frameworks that's actually being supported. So there was a question earlier about what exactly you can then use from .NET Standard if all this magic's happening under the covers. So we know for a start that you can use .NET Standard libraries in any of the stacks that are supporting .NET Standard at that moment in time. So we know this is things like .NET Framework, .NET Core, Xamarin, and then extending out the side with things like Unity as well. You then have your library, and your library can just be your code on its own, or it can have other dependencies. Those other dependencies can be a .NET Standard library that is supporting at least the .NET Standard target that you support. So if you're supporting 1.6, that library needs to support at least 1.6 or lower. You can reference portable class libraries. So there is ways of you taking portable class libraries and upgrading them into .NET Standard, but you can also make a reference directly to the portable class library. Again, as long as you are supporting you're supporting a profile that is linked to the standard library footprint that you're trying to target. And then through the compatibility shims that I showed you in 2.0, you can now also reference .NET Framework libraries, as long as you're not trying to call .NET Framework libraries that have APIs that are not supported, like XAML, WPF, and things like that. So how this magic fits together is something like this. So we've got we have the Net Standard DLL, which is the assembly, the reference assembly that comes down in that NuGet package. What will happen when you start to reference your existing .NET Framework class library, your portable class library, is you essentially are going to get two different types that are going to be in play here. So you're going to get your .NET Standard based class library. You're going to start to use things like objects. Because of the way the BCLs reference these, what you'll actually see is if you actually start to create an object under a .NET Standard class library and you reference an existing .NET framework, you're going to get a type mismatch because the type that's coming out of the existing .NET Framework library is actually of type MS-CoreLib object, because the .NET Framework class library is actually using MS-CoreLib as its base class library. .NET Standard is using Net Standard as its base class library, so when you start to create objects, you're actually creating a Net Standard object. And these differences will cause compiler issues. So the reason we have these reference assemblies is if you reference a existing .NET Framework class and call a type of object, what will actually happen is a compatibility shim will be inserted within that framework, which will actually just be another type of facade. It'll be an MS-CoreLib reference assembly, which will again be completely empty. And what it'll actually start doing is it will type forward everything you're asking for back into the .NET Standard library. That way, when you're getting your object back again, your object actually has inherited from the Net Standard object as opposed from the MS-CoreLib object, and you can actually start to use the interoperability between the two libraries. If you go the other way around, it actually works the same in reverse. So if you've got a .NET application that then calls a .NET Standards class-based library, what will happen is your .NET application will use MS-CoreLib as its base class library, and it will need to start accessing things. So we've actually then got the .NET Standard reference library that will then call back into, it will type forward back into the MS-CoreLib, get objects back again, pass them through, and they'll become interdependent. So I just want to quickly touch on how all of this is now linked to .NET Core. So this is the final piece in the puzzle. Is the reason we want to start standardizing stuff is to make things great, work together between the stacks we're playing with. But the evolution of .NET Core is why everyone are really excited of how we can take our existing .NET applications and get them working on OS X, on Linux, and other systems. So firstly, I just want to reiterate that .NET Core is an implementation and conforms to the .NET Standard. They are fully separated and they have different GitHub repositories. This wasn't always the case and has led to some confusion. So the original .NET Core and .NET Standard base class library were one and the same. This caused issues for Microsoft when they started to develop .NET Core because they wanted to run as fast as they could with .NET Core, but they did want to standardize from a standards perspective. But .NET Framework, .NET, sorry. So what they've done in recent times is they actually decided to completely decouple the .NET Core versus the .NET Standard. So we've now got .NET Core using the system.runtime base class library, and then you've got the .NET Standard using the standard frameworks piece that we just looked at. The other thing to call out here is .NET Standards is a standards board. So when people want to add to the standard, they actually come together, and we've got representation from .NET Frameworks team, from Xamarin, from Mono, from the .NET Core team, and they all have to agree that the new API set is actually going to be standardized in this form. This is good for .NET Core because it means that as long as they meet that standard, they can go and add as many additional APIs in as they like now without breaking the standards confirmation that they've moved to. It means that they can experiment and accelerate as quickly as possible, and we're always now going to see a decoupling of .NET Core versus the standard progressing. What that means is the releases are going to be now completely staggered compared to what we originally saw with .NET Core. So .NET Core 1.0 was released in June 2016. .NET Core 1.1 was released in October 16. We're now seeing .NET Core, I think it's now called 2.0. It was originally out as 1.2. That's coming out with the release of Visual Studio, or around the release of Visual Studio 2017. The standard, however, isn't as clearly defined in terms of the release. The standard will be released when the standard has matured. So our current release standard is 1.6. That's the one that's in production. That's the one you can download in NuGet. 2.0, the timeframes we've had talk about is at some point after Visual Studio 2017. The maturity of the new .NET Core needs to be a priority. The tooling needs to be a priority. Then the standards board will figure out what the next level of standard is, and that's when the maturity will come. However, in the new world of Microsoft, all of this stuff's on GitHub. So as I've done, you can go on to github.com/.net/standard, download 2.0, and start playing with the preview releases of this. You just need to download it, run the build scripts, and then you can start using it inside Visual Studio 2017. So that's all I've got to talk about. I'm hoping it was somewhat of interest to you. So quickly in summary, just touching across some of the points that I've made today. The .NET Standard is a standardization of the base class libraries across all .NET platforms. Library developers can target breadth and depth based on particular version numbers, and the place to find out the sweet spot that you need to go to is on GitHub. The advice that is commonly given is try and target the lowest number possible. The lowest number possible would give you the biggest developer base, but if you need particular APIs, that's where you're going to get throttled about how far you can actually go. There is a call out that this will start to replace PCL over time. I think no one is overly ambitious to say PCLs will die tomorrow because we still have a lot of investment in PCLs, but as standardization does conform within the .NET stack, the need for PCLs starts to move away, and .NET Standard will hopefully be the way we can start to now code against these APIs. .NET Standard 2.0 is designed around enterprise capability and greater API support. It's more than doubled the amount of APIs, in around 32,000 APIs that are predominantly coming across from a .NET framework, and it's adding that enterprise level support for things like serialization, the current reflection APIs, and XML. Also adds the compatibility shim, which means we can take the investments we have in the .NET framework and start to use them in .NET Standard and eventually onto .NET Core 2.0. And there's plenty of tooling around to support you through this journey. So get onto GitHub, get onto some of the free tools I've shown you on the hosted tool sites, and start experimenting with the codes you've got back at home to see whether you can get this stuff into the standard and onto Core. So with that, that's all I've got to talk to you about, but I've got plenty of time to answer any questions that people may have.
So my question is around the NuGet packages. You know, when you create a project, it adds lots of NuGet packages that you don't have. So is there any different sets of NuGet packages for .NET standards, or it's different?
So the question was, is there any different sets of NuGet packages for .NET Standard, or is it different? I don't actually know the answer to that, and I'm going to look at the back of the room because Nick is also... is there different sets of NuGet packages based on .NET Standard targets?
Yeah, well, it's different individual versions. When you change the .NET Standard version with the target, it does change the version of the NuGet packages. It's not as bad as changing PCL profiles. Generally, Studio handles it for you. But definitely 2015 has got a few new little
So,
2017 is much better.
so the answer from Nick is yes, you can change the target of NuGet based on .NET Standard. I've not actually played around with that myself. The tooling's still being developed around some of this stuff, but Nick's been playing around with it from some of his Xamarin work. So that was the answer he's given us. Any other questions?
Speaking about Xamarin, in your first example of Xamarin Forms App, you show us that you cannot add Calibre Micro into the project. Taking all this into account, can you fix this error?
Yes, you can. There is a way of actually fixing it. The way I fixed it is I used a different PCL profile. So I actually changed my PCL profile to conform to the one that's actually submitted into the NuGet package library. So I think I ended up adding ASP.NET and UWP in, and it actually changed my target number, and then it actually referenced. But having a conversation with Nick earlier, he was saying that there's a way of actually changing the CS proj file to put an import statement in, which will actually allow that to play out as well.
Probably one of the most common problems that you come across in terms of the between PCL-based libraries and .NET Standard is when you're trying to work between them, and a lot of libraries that are out there at the moment are PCL-based because they've been around for a while, right? And so what you'll do is you'll go and create your .NET Standard library, and then you're going to want to import one, and then Visual Studio will complain, you'll go, and then you'll go hunting on Google, and you'll spend like days trying to work it out. Basically, in 2015, you have to go into the project JSON file, and you need to insert an import statement. And it's not as simple as I can't tell you exactly which one you need because it's kind of based on the profile of the project you're trying to import. So feel free to reach out to me if you want more guidance on that. 2017, they've changed the project structure for the .NET Standard libraries, and it's now back to being a CS proj as opposed to being an X proj. So there is no more project.json, thank God. And basically now you have to go and modify the CS proj file, and there's a particular reference you need to put in there. That part is currently a little broken in the current RC build, but again, there are workarounds for it, and feel free to hit me up afterwards if you need it.
So the reason I keep pointing at Nick is for two reasons. Firstly, this was Nick's original session, and he delegated it down to me, so he's another subject matter expert in this area. But also, he's had some pains that we've been talking about over the last few days of the evolution of, as you mentioned, projects.json is moving away in .NET Core projects, and they're folding that back into the CS proj structure. So we've been talking backwards and forwards while Nick's been in contact with some of the framework teams around some of them changes and some of the pains he's having to go through to fix some of this stuff. Is there any more questions?
Yeah, does this remove some of the need for the assembly redirects, app.config files, if you're targeting .NET Standard in your application?
If you can get the right level of API support, then yes. What this is essentially doing the same thing. It's doing type redirects for you as part of that compatibility reference assembly. So if you've got the API coverage you need, if you don't get that API coverage, you're always going to have to fall back to those approaches. If there's no more questions, I'll be downstairs in the speaker lounge for the rest of the day and most of the day tomorrow, so feel free to come and seek me out. Also recommend Nick Randolph, who's a Microsoft MVP in this space, so go and chase him down as well. Thank you for your time.